Hello again. These last two videos in this MyStatLab assignment are from 5.3 and they are closer to real life. And it says, number 17 says, the time spent in days waiting for a heart transplant in 2 states for patients with A positive blood can be approximated by a normal distribution with a mean of 129 and a standard deviation of 22.3. What's the shortest time for a heart spent waiting for a heart that would still place a patient in the top 30%? So in other words, what's the cutoff for the top 30%? The lower cutoff. So you're looking for an inverse norm. You need the area to the left, and the area to the right is 30%, so the area to the left must be 70%, or 0.70. The mean is 129, and the standard deviation is 22.3, and we're looking for a number more than 129 days, and we get 141 days approximately. Now part B says, what's the longest time spent waiting for a heart that would still place a patient in the bottom 25%? Focus on the bottom and the top and don't stress so much on the longest time and the shortest time. It gets confusing to students every single semester. I'm going to go ahead and second entry because I can just go up here. Since it's the same mean and the same standard deviation, and the bottom 25% means 25% to the left. Oops, it helps to, if you're going to do this, it helps to do it right. 0.25, comma, 0.129, 22.3. This number should be less than the mean of 129, and it's 114 approximately, 114 days waiting for a heart. Now, last one for this section. Average time spent sleeping in hours for a group of medical residents at a hospital can be approximated by a normal distribution as shown in this graph. 5.9 hours and 1 hour. They sleep a lot more on average than I do. And they ask residents who get at least how many hours are in the top 5% of sleeping times. So we're given a percent, 5%. So we don't need a normal CDF, we need an inverse norm. Top 5%, 100 minus 5% gives us 95%. So 0.95, comma, 5.9, comma, 1 hour. Enter. Wow, that's a lot more than I sleep. 7.54 hours approximately. That's the end of this section. I'll bet you're happy, and more later.